All right, let's get this going. Lower down my own volume. Okay, here we go. I had some background music playing, copyright free. Hopefully that made it into the live stream. We'll find out on the recording. Okay, for tonight's agenda, we're going to be looking at inputs. When you get those inputs, they usually come in as strings. We're also going to look at how to get them as numbers, such as float and integers. Then we'll be looking at more string formatting. We looked quite a bit at strings and how to format them in week 1 and week 2, but there's still more to learn, which makes sense because when you think of the large body of knowledge that is humanity's writing, almost all of it is writing. Whether it's a form of a book, whether it's a website, it's all writing. It's all text. So being able to edit it, format it, break it apart is all very important stuff. So a lot of Python is about data manipulation and data ingestion. Then we'll be looking at string concatenation, such as the naive string concatenation, which everybody seems to love, as well as the dot join. We'll be looking at string.format for formatting, f strings for formatting and joining strings together, and then we'll be looking at the percent format specifiers. And then finally, we'll be finishing off with my favorite, the readability, simplicity, and efficiency. Because as mentioned before, your code is never for you. It's always for whoever the next programmer, whatever company or job you're doing is, or if you're on a team, for the other programmers that are on your team. The code isn't just for you. You're writing for other people to read it. Okay, so without further ado, let's jump in. We'll look at inputs. Okay, so let's say we want to get an input as a string. I have a simple snippet of code here. Let's see, let's zoom in so it's a little bit bigger. There we go. So if we look at our inputs, get an input as a string. We're going to take in a hero name. So let's say you're making a game such as I'm working on my Pi RPG game. And as we move into the more advanced Python stuff, we'll get more into how to use this stuff for a text-based game. So you want to get the hero's name when they're doing their character creation. So we can use the input built-in function, and then you just put in what you want to display to the user. You could leave it blank and it's just going to wait for any kind of input, but the user may not know it. All right, so I mean, you could do something as simple as input blank blank, and it'll sit there and it'll just wait for somebody to push something. It's a good way to actually end your programs too. You could put it the input there and put the press any key dot dot dot, and then once they press any key, it quits the program. So it's a good way to just keep the program from going straight to Windows and actually pause at the end of the program, waiting for the person to push enter or something along those lines. Okay, so if we run this little bit here, okay, connecting back up to the engine, you can see that right here. So whenever you have Google Colab, you connect to an active session. Okay, there we go. We have an active session and it's running it. So since we're doing an input, it's going to wait. And Google Colab is nice because it makes this little text box here. So let's say we want our hero's name to be Roland, and we hit enter. Okay, so we're doing a print statement, type of hero name. I think we looked at types last week, but if not, well, this is how you can check a variable type. In fact, I know we looked week 2, we looked at data types and how to find out what they are. So you have your variable and you just type, surround it with the type function like this, and it's going to tell you. So all inputs in Python come in as strings, and we can see that with class str. And then if we want to print it out, we can use a formatted string, put it inside the curly braces, and we also looked at this last week on how to export some nice, easy tip ways. And here you can actually put the variable name, and if you put the equal sign on here, when it prints it out, it'll actually print out the variable name, the equal, and it will also include the value of it as well. So for those that didn't see it last week, this is a quick look on how to do it. If you put just the variable without the equal sign, it'll put just the value Roland with the single quotes, showing that it is a string. Okay, so let's say if we want to do this as an integer. Okay, so let's get in an integer, which is a whole number, a non-decimal value, and we'll say, what is your age? Okay, let's say 19. Okay, press enter. But if you look, the type is still of type string. And then when we actually print it out, it comes out as 19 with the single quotes on it, which means it is, in fact, a string, not an integer. So what we can do is typecasting. We looked a little bit at typecasting last week, but we'll look at it quite a bit more here, especially when it comes related to input. So we can do typecasting. So let's cast this as an actual integer. So what we'll do is we'll go ahead and we'll get an input. What is your age? We'll store it inside user age. For those who are joining, we use camel. We're using camel case here at Leeward, where the first word is all lowercase, and then every word after that starts the first letter with a capital letter. So lowercase user, capital A for age. And look at user age equals what is your age. And then what we're going to do is we're going to typecast, like we looked at last week, as an integer. So you put int, and then you put the brackets, and it's going to change or typecast the value of user age, and then store it back inside user age. And then we're going to go ahead and print it out and see what happens. So let's say, what's your age? Let's go with 20 this time. Press enter, and it casts it as an integer and stored it back inside user age. So when we check the type, we get an integer as the type. And then when we print it out, it's user age equals 20. And if you notice, it does not have the single quotes on it. So it is indeed an integer, not a string now. All right, let's go down a little bit more. Okay, casting an input to integer. So we can cast it when we get the input. So instead of doing it two steps like we have here, we have the input line, and then we store it inside user age. Then we change it to an integer, store it back inside user age as an integer this time. We can actually do it when we get the input. So to do that, you have your input with its parentheses, and then all we do is you place int inside those parentheses. So we just take int, parentheses, and inside in here, we're putting our input inside those parentheses, just like that as an example. Comment that out so it doesn't try and do it. So let's go ahead and run it and see what happens. So what is your age? Let's go with 21 this time. Okay, press enter. And without having to have it as a second line, it's casting it as part of the input. And look, we get class equals integer and user age equals 21 without the single quotes, so it is indeed an integer. Now, let's say we want to get an integer, but somebody inputs it in as a float. Sometimes in surveys you'll see, the average family has, 2.7 kids. Well, I don't know how somebody would have 2.7 kids, but when you're talking averages, it will break up overall. So if you had 10 families or, 100 families, they'd have, 27 kids. Then it'd be a whole number in that case there. All right. So we can get it from the integer from input, but if it has a float value, it can give us an error. Well, we can catch that error. We'll see in a second. It'll actually give you a value error. And that tells us, hey, you can't get this integer from the string. And if it's a float, what it has is it has that decimal in there. So it might be 2.7, but it took it in as a string. When you try and change the string, and in a decimal in a string is a period. It's not a decimal because it's a string. When you convert it over to integer, it won't know what to do with a period in the middle of a sentence because a string is a sentence. So we're going to get a value error. So what we can do is we can handle that. There's a couple things you can do. I'll show an example of how to use a try, except, else. Finally, we'll actually just end up using the try except part here. But this is a structure within Python that actually lets you catch errors before they actually crash the system. So we'll look at that in a second. But first, let's put in a float value such as what's the average cats in a household. Okay, so what we're going to do is we're going to take in what is the average number of cats in a household as an input, and we're going to try and put it as an integer and store it inside the variable and see what happens. Okay, let's say the average number of cats in the household is 3.3. It's going to bring us a string, so that's going to be 3 period 3 as far as strings are concerned. Now look, we got an error. And if we look, it is a value error, invalid literal for integer with a base of 10 because numbers are a base 10. And because it has it in the single quotes here, it thinks this is 3 period 3. So a sentence with a period in the center there. Now, if we try and make this into a float, it'll understand what it is because it'll understand, oh, there's a single period in a sentence. Well, that must be a decimal because we're making it a float. But an integer doesn't understand that. So what we can do is we can actually use this try except block that I just mentioned, and we can go ahead and try and catch that. So what we'll do is, let's see. Oh, no. First, we're going to go ahead and show how to do it correctly. Then we'll go ahead and look at the try-catch block. So what we're going to do is we're going to take that input. We're going to cast it to a float first because the float understands what that period is. So a 3.3 period 3, when we turn it into a float, will become a 3.3. And then going from a float to an integer, well, they're both numbers, so it'll just drop the decimal 3 and it'll just keep that whole value 3. So let's give it a try. So what is the average number of cats in a household? 3 period 3. Enter. And look, it successfully did it by taking it from a string as the original input, casting it to a float, and then casting it to an integer. Then we go ahead and print it out. It says that is an integer, and it took it as a 3, not 3.3. So in this case, we lost precision in our number because we turned it into an integer. So we can also look at a try block. So a try block looks a little bit like this. You do try, you tell it what you want it to try, and if it has an error, then it'll go ahead and do an exception, like tell you, oh, this does not work, but it doesn't crash. So let's hit play. What is the average number of cats in the household? 3.3. Enter. And since that crashed because we're not converting to a float first, we're just doing it straight to an integer, it went to the exception for a value error. And it said, what the text we have there, invalid input, please enter a valid number. So instead of crashing our program, instead it popped out an error message that we wanted to display. And in this case, that's not a valid input. Input a valid number, such we say input a valid integer number, right? Hit play again. What is the average number of cats in the household? And 5.7. You can see the text is now updated to a valid integer number. Okay, we'll put a valid integer number, 5. Enter. There we go. Class int average cats in household is 5, and that's because we did not put it as a float first. So going up just a little bit, if you want to get a value that could potentially be a float from an input, we have to go input first, which is a string, cast it to a float, and then cast that to an integer. So we'll hit play again. 3.9 as an example. And when we do it, it cuts off the .9 and it leaves us with a 3 as the integer. All right, so let's go ahead and take a look. So let's see, that was strings, that was how to get an integer, and that was how to get an integer if there was a decimal in that number, or how to cast it to a float as well. So you can cast it to a bool, string, or you can cast, so any variable can be cast as a string, but when you do an input, it comes in a string, and then you can cast it to a bool, a float, or an integer. And we talked a bit about casting last week, so this is just a refresher on that and how to incorporate it in with an input. So moving on next, more string formatting. So there's lots of special commands you can use to format the text specific ways that you want. Let's say you want a user to input something in like, would you like to play again? They could type Y or N or yes or no. Now, if you check, if play again equals Y, then play again. If play again equals N, don't play again. But N and Y have a capital letter and a lowercase letter, and you don't know which one your user is going to input. So what you can do is you can just say, if play again equals capital N, then then quit the game. And what you can do is, if they input a lowercase or capital letter, you just force it to become a capital letter. So here are some of the different commands you can use. We have string.upper. So any string you put in there, you can say, hello, my name is .upper, and it's going to force that hello, my name is to all be uppercase. Lower is for lowercase. Title is for title case, where it's capitalizes the first letter of each word, kind of like in a title or a book. You have capitalize, which will capitalize the first letter. Then we have swap case, which will take the whatever capital letters and lower cases you have, and it's just going to swap them. So if you had it as capital title case, the first letter of each word is going to be capitalized, and it's going to go ahead and make that first letter lowercase and make all the other letters capital letters. You could use this if you're trying to fix everything from one format into another format. And then we have strip, so we can take out any blank spaces on the left and right side of a word or a sentence. Left strip only takes out the left side blank space, white space it's called, and right strip takes out the white space from the right side. So let's go ahead. I've got this shrunk down, so let's expand it out. Okay, so let's look at some examples of this one. So we have two strings. We have the first string. This is the first string. And then we have a second string variable, and you can see that it has quite a bit of white space or blank spaces on the left side and the right side. So if we run this, here we can see we put each string inside a print statement, and then we went ahead and put, what we're doing to it. So when we hit play, we can come down here. So this is uppercase, makes it all capital letters. Lowercase will make it all lowercase. I think I put this is a string, yep, starts with a capital T, so there is a capital letter in there, and you can see everything is lowercase. Title case is the first letter of each word is capitalized. Capitalized, or using capitalize, will take the first word of the sentence and make it capital. So in this case, the word this will be capitalized while the rest of it all stays lowercase. And then if we wanted to swap the upper and lower case, we can use dot swap case. So now this becomes lowercase while the rest of the entire sentence becomes capital. And then for our second string, we had all that extra white space. So if we use strip, so just like here, if we use string dot strip, it's going to take away all the white space to the left and the right side. If we use left strip, then it's only going to remove the blank or the white space or extra spaces from the left side, but it's not going to touch anything on the right side. And if we only want to strip the right side, it's not going to touch anything here on the left side. So all these blank spaces here, but it did strip them from the right side. So this becomes beneficial. So we're going to look at concatenation of strings. If we want to put strings together, well, then there also has to be ways to break strings apart. And when you break strings apart, there's spaces inside those strings. Well, strip left, strip right will allow us to remove any extra spaces, so we get only the words left over for that particular piece of the string that we want to get. And I think we'll be looking at breaking strings apart using slicing. I think that's next week's topic. So, but just so you know, there is the strip command, so you can remove any extra white space. So let's go ahead and combine strings together, or concatenation. There's a couple different ways to do it. So we have naive string concatenation. Starting with week 1, we looked at that one quite a bit. That's when you use the plus sign to combine your strings. It is not an efficient method of combining lots of strings, and it's also a method that you should not use when you're doing loops. You have your string.join, which is an effective way to join strings together. We have f-strings, which allows us to join variables and strings together, combine them together into an easy-to-read format. Then we also have format, which is another method of displaying strings similar to f-strings, so we can get variables integrated in. And then finally, we have the percent operation, which will allow us, and this is not modulo, okay? So this is not arithmetic. This is the percent. So you'll see in a little bit here exactly what I'm talking about. But this is also similar to f-strings and format, as in allowing us to put variables, formatted variables, into our sentences. So looking a little bit more at naive concatenation. So this is the first form of combining strings that we learned. It uses the plus operator. So you have string 1 plus string 2, or if you want to add an extra space in there, you could have string 1 plus a blank space plus a second string, and it's going to combine them together. If you only have a couple strings to combine together, like 2, maybe 3 strings, this is a great way to very quickly combine them together. But if, let's say, you have a book that you're scanning line by line from an external document into Python, you're going to have thousands upon thousands of strings, and you don't want to use the naive string concatenation to combine thousands of strings together. If I don't have it actually written out here, we'll talk a little bit about the way strings are combined together and how they're parsed, which results in this not being an effective method. That might come at the end. If we have time, we'll talk about it there. But for now, just remember, naive string concatenation, simple to use, and it's great for a couple strings at a time. If you have thousands of strings, it is not efficient, and you should definitely not be using this for loops, which often combine lots of strings together. So we learned this in the beginning, but we'll just do a quick review. So naive string concatenation, we probably didn't learn the term naive string concatenation, but that is the official term for using that plus sign. So we have our first string, we have our second string, we want to combine them together. You can see there's no blank space at the beginning or the end of either string, so we want to add a blank space in there as well. So we'll do first string plus a blank space plus the second string to combine it together, and we'll go ahead and print it out. We can also, instead of saving it as a third string, we'll just go ahead also and show that you can just do it straight as a print statement. Okay, so we'll run it, and look, they both look identical. This is the first string, they both have a blank space, and this is the second string. Now, the reason you don't want to do this for thousands of strings, what it's going to do, it's going to look at the first string, and it's going to parse through that string, say, okay, how big are you? Okay, you're this size. And then it's going to look at the second string and say, okay, how big are you? Okay, let's combine you together as a third string. In this case, we're saving it as a variable, but even in this print statement down here, it's taking the first string, combining it with the second string, and it's still making a third string in memory. And that third string in memory is this string here. Now, if we did plus another string, then what it's going to do is it's going to parse all the way through this string as a new string, and then it's going to do plus another string. And then it's going to make a really, really long string. And then if we add another string to it, the string just keeps growing and growing, growing, and it has to reparse the string, the new string it creates every time. It has to reparse it when you combine it with yet another string. So for 2 or 3 strings max, naive string concatenation is the best method for simple operations. However, if we want to look at something a little bit more efficient, let's say we want to join a bunch of strings together. So here we have 3 strings. We have first string, Leeward, second string is community, and the third word is college. So the string.join method is an efficient method for combining strings together to include using for loops. If you have a lot of smaller strings, or you have a lot of really long strings, you have paragraphs, you have pages from books that you've scanned in, you can use this to join them together very efficiently and quickly. All right, so we can combine these together. We haven't looked at lists yet. That comes in a couple modules, but just know that this is a list here. So basically what all a list is, it's just taking multiple items and grouping them together. So this is item number 1 or 0, because we always start at 0 in computer. So this is item number 0, this is item number 1, and this is item number 2 for a total of 3 items. And we're going to use it, we're going to take a blank space and we're going to join each item. So we're going to do first string, space, second string, space, third string. Let's go ahead and print that result out. Okay, and here we got Leeward Community College. And just to show you that the blank space actually does add a blank space, let's go ahead and use it with an underscore. So we'll go first string, underscore, second string, underscore, third string. And you can see the second example here, Leeward underscore community underscore college. So this is an easy way to join lots of different strings together. That is also an efficient memory and processor efficient method of joining strings together. All right. Let's say we want to use, let's say we're going to get a little bit more into the formatting side, but this is how you combine variables into your strings. In my week 1 and week 2, we looked a little bit at the F strings, because that's my preferred method, and but what I've seen in the industry, that is also the preferred method there as well, because it is the most readable way of doing it. But first we're going to look at format. So this is similar to the way that you might see in other languages, such as Java, C++, things like that. So we have the word Leeward saved in a variable called school. We're going to look at it. So just like format, there's a set of curly braces, but the curly braces are empty, and there's no F at the beginning of the sentence. So this is just a straight dot format similar to other languages. So you do curly brace, that tells the compiler that, hey, a value is going to go into this position here. And it's going to say, is a great place for learning. So this is our string here. And then at the end of the string, you do a dot format, and then you put the variable that you want to take its place in here. So we want school. Okay, and here we're saving in the value of result. Just wanted to demonstrate that you can also do it straight inside a print statement. You don't actually have to save it and then print the variable itself. You could just put the statement straight inside a print function. Let's hit play, and you'll see the result is the same. So it took the bracket, and it replaced it with whatever value was stored inside school, which in this case was Leeward. And Leeward is a great place for learning. All right, let's look a little bit more at .format. So you can use this to do advanced formatting. Let's say you want to look at decimal places, or you want to set them significant figures and things like that. We can go ahead and look at it this way too. And we can do rounding of values, significant digits, set a fixed number of decimal places. So if you see the F, like right here, this stands for fixed, so .2F, 2 fixed decimal places. I believe we talked a little bit about this in week 2 also, but now we're just looking at it more in the formal structure of a .format method. So an example, we have a quantity of 3. Each of those items costs $5, and the total cost will be the quantity times the price. So we got a little bit of arithmetic going in here as well that we talked about last week. And then we put in a print string, we're doing curly brace, items at curly brace with a format in there. So we do colon, and then we're doing 2 decimal fixed places. So always show 2 fixed decimal places. And this is probably going to be a dollar value because we got the dollar sign there. Each is, same thing, a dollar sign. You do your colon, and then after the colon, you do your formatting. So 2 decimal places of a fixed length. So always 2 decimal places total. .format, and then the first set of curly braces is going to get the value of quantity. The second one here is going to get the value of price, and the third one is going to get the value of cost. So this demonstrates you can have more than one variable inside your sentence. So let's go ahead and hit play, and just to make sure it works, okay? And it does. 3 items at $5, each is $15 total. Pretty simple, right? Now, the issue here is that it's not super readable. With F-string, things are much easier to read, as we see down here. So in prior weeks, we used F-string quite a bit because of the easy to read format that it comes in. So the format is you have the F value, then you have your string quotes right here afterwards, and then you have your string. My string is curly brace with the variable inside the curly braces here. And the reason we could put the variable inside the curly braces, unlike format where they had to be empty curly braces, is because we're telling it, hey, this is a formatted string. This is an F string, by putting the F just before the string itself. Okay, and to set that, you just have to put that F as the preceding letter. Okay, so let's look at basic F strings. You can take in, a variable with the name of Alice, who's 25, and we're going to save this one inside a variable, but you could also put this statement right here directly inside the print. And we're going to say, hey, this formatted string is my name is name variable, and I am age years old. So we know just by glancing at it exactly what this variable is going to be giving us and what the age is going to be giving us. This is going to be the variable or the value that's stored inside name. This is going to be the value that's stored in age. And that's a little bit better than having to look up and see the variables at the end and then have to match up mentally which variable is going to which position within the sentence. Let's go ahead and hit play. And it puts it in line. My name is Alice and I'm 25 years old. We can also do rounding and limiting on decimal places using F strings by specifying the precision. So similar to how we did it in format, you can use colon and then use the number of decimal places that you want to do, and then you can put a format. So it's as fixed decimal format where n is the number of decimal places. So an example, let's say you have pi of 3.14159265358979, just in case anybody didn't want to read it, and we stored that in a variable called pi. Now in this case, I would actually probably go pi with capital letters because this is a constant, right? Just like we learned in week 1 or week 2 with constants, pi is a constant value. Pi never changes. Pi is pi. So best to be in capital letters. We have our value of pi. And look, if you mouse over it, I believe it says constant now next to the word pi there when you mouse over it. So Google Colab is intelligent enough to tell us, hey, you have a constant value here. Okay, and then we're going to do a formatted string, pi rounded to 2 decimal places, is pi colon, and then how many decimal places, and we want that to be a fixed value. Always use 2 decimal places. Print. Pi rounded 2 decimal places is 3.14. Easy enough. Last week we looked at the math library when we were discussing arithmetic. For arithmetic, it gives us some advanced functions, including math.pi. So while the pi value we typed here has a limited number of decimal places, the pi here is mathematically correct, mathematically accurate to an infinite number of decimal places. And then we can put that in the brackets, and then we can also format that with the .2f. And then we can also, the math library also, if we wanted to convert it from degrees, because by default math.pi is in degrees, we can also convert it into radians. So hit play. And so pi rounded to 2 decimal places is 3.14. Pi in radians is 0.05 and a nice long number there. We could turn that into scientific notation if we wanted to. Okay, let's say you're working in chemistry or physics or some other scientific field, and you have to be precise on the number of significant digits. So when you're taking a science course, some of you may or may not have taken physics already, or continue on to advanced science degrees. Significant digits means what is the highest degree of accuracy that we can say for sure within our numbers. So if our original input only had 3 significant digits, then our final value has to be rounded to 3 significant digits as well. You don't want to round any of the intermediate steps, but let's take a look at what this looked like. So you take your input significant digits, and then you leave all your intermediate calculations as they are. You don't round any of the intermediates, but your output, your final number value, has to have the same number of significant digits. So let's say, for example, we have this number here. We went to 4 significant digits on our decimal places, and we want to ensure that we go to 4 significant digits. Ooh, try to say that 5 times fast. 4 significant digits on our final output number. So what we can do, so we have this one here. There's a lot more than 4 significant digits here. Sorry, let me make that clear. There are more than 4 significant digits in the variable number here. The final output, so let's say our input was temperature of the sun in Kelvin as an example, or we'll even go Celsius, and it was 156 like that, 1,560 degrees Celsius. Totally don't know if that's true. Somebody can look that up if they want, but let's say we have 4 significant digits. If we were to divide that, we might get a crazy number, 1,560 divided by 2.5. Okay, let's see what that gives us real quick. 1,560 divided by 2.4, and see what it gives us. Do a little bit of programming on the fly here. Let's scroll down. Okay, that gave us 650. Let's get something with a little bit more decimal places. There we go. Nice big number here. So if this was our final output of what it would be, on an average day, this is way too many digits. Our ingoing value only had 4 significant digits going in. Therefore, we can only have 4 significant digits here. So as we demonstrate down here, we have a very big number. We want to limit the number of significant figures. So this is for science-based subjects. What you could do is you could use the number of decimal places and then use the G value here. So before, if we scroll up, we used F for a fixed number of decimal places. Here, we're not looking at decimal places. Here, we're looking at significant digits. So I'm going to hit play or run, and we'll see how it goes. So we have 1, 2, 3, 4. 4 significant digits times 10 to the 4. So add on 4 additional decimal places. Would actually add in a 5th 0 in here. Let's go ahead and get 4 significant digits on our sun value here. Okay, what we will do is we will make this into a formatted string, because that's the section we're in formatted strings. inside the formatted string. Let's go ahead and put some parentheses on these just to keep everything together. We want our colon dot 4G. Let's see, will this run? No, because I need a quote here. Okay, there we go. Now we got properly formatted string with F on the outside. We have a variable here with a math operation going on inside that has to be evaluated. The evaluated math here will then be set to 4 significant digits. Let's hit go, and there you go. It is 678.3 because it is 4 significant digits. If we would have said 5, let's go with 5 because let's say that was a 1 right there. It'll add in 1 more significant digits. And that is scientifically the correct way for your final output value to be rounded correctly. So Python is very good at science and mathematics and engineering utilization because of things like this. All right, whew, let's get away from significant digits. That was a lot of work on that. Okay, let's look at formatting alignment. We looked a little bit at formatting in week 1. We looked a lot at formatting or alignment in week 2, but I just wanted to go out and show it a little bit better, a little bit clearer, because this is going to be one of our big last weeks on alignment. And in assignments I saw turned in this last week, there was still quite a bit of issues using the alignment operators here, or using string.center, right adjust, or left adjust, or left justify, right justify. So I just want to go over it one more time with examples in Google Colab, so that way if anybody has any questions, they want to check it out later, they can come on here, watch the video at a later date and say, oh, how was that right justify supposed to look? And they'll be able to see 2 working examples easily in Google Colab on how it's supposed to look. So let's use the arrow alignment operators. Okay, so doing alignment with the symbols and escape characters. Okay, so that's another thing. So you can use escape characters to break a single string into multiple lines of text. I know that was one of our assignments, and some people still messed up on breaking text into multiple lines. They would make it as a string and then concatenate it with the plus sign, another string, plus another string. It got kind of messy in there. So this is one string. See, we only have one set of the double quotes. It is a F string because we have the F right here. We can see we have a variable and some text. We have another inline variable and some text. And we have another inline variable and some text. If we hit play, what we should see is we should see name. It is left aligned in a 10 character space. So total, regardless how big the name is, going to give us 10 characters of space, and it's just going to pad in white space and a left justify or put the text to the left. This one here should be name right aligned in a 10 character space. And this one here is name variable centered in a 10 character space. Let's go ahead and print just to confirm that. And there we go. Alice is left aligned, Alice is right aligned, and then Alice is centered. So there's a perfectly good example for everybody to look at using the arrow, or in this case, I guess it's the less than, the greater than, and the caret symbol, which is Shift 6 on your keyboard for centering that text. And then we'll look at one more time looking. I know I showed definitely the center. So if we see the variable dot center with 10 spaces, I know I definitely showed that one in week 1 and definitely week 2. But I did not show previously the left justify and the right justify. Okay, and it does the exact same thing. So we'll hit play, and it looks identical to using the caret symbol. So you pick which method works best for you. Do you want to do it with the colon and then left or right justify with the number of spaces to maintain, or do you want to use it as a function formatter or string formatter of less justify? So you put the string period left justify and the number of spaces. This is a string formatter. All right, and it'll come out the same thing. So pick whatever method you like best and stick with it. You should know both, but pick whichever one wants, because when you're building programs, consistency is important. So if you start using the string method, by left justify, right justify, and center with the number of digits, do that for your entire program. And don't change that until maybe you go to another program. Or if your company wants to do it with using the caret symbols, then do everything you do in that company using the caret symbols, the less than, greater than, or equal, or the arrow operators, whatever you want to call them. And just pick one method and stick to it. Okay, let's say we want to pad our numbers, okay? Let's say we have the number 1, 2, 3, and we want to pad it with zeros on the left side because no matter what, we want it to be 5 digits long. Or let's say we're talking time. Let's say the time is, you're talking military time, and the time could be, you know, it is 0001 in the morning for a military person. Well, those left zeros are called padding. And what it does is just takes whatever number of digits you have, and it forces it to be a certain number of digits. All right? So in this case, we're going to take the number 1, 2, 3, and we're going to pad it with zeros on the left side. So we're going to take our number, colon, right? Because most of our operators are utilize colons here, because these are not string operators. These are actually our F-string formatters is what they are. And we're going to do 5 spaces of alignment. I think it actually gave the value. Mouse over that again. See what it said. Okay, there we go. Yeah, it just shows a float number. But yeah, it's going to make it 5 spaces, and D is going to tell it that this is a padding. So if we hit run, which you see, look, number padded with zeros is 00123. Let's say we were talking about that military time though. All right, let's say our number was, it is 1 in the morning. Well, nobody gets up at 1 in the morning. Instead, if you're looking at military time, you get up at 0001 in the morning. So basically 12:01 a.m. Nobody should be waking up at that time, but if so, so be it. And we're going to go ahead and pad that to 4 spaces in total. And when I hit run, it is now 0001. And we could call that, we don't really say AM, but that is on a 24-hour clock. So there we go, 100 hours, 100 hours. So number pad of zeros, this person woke up at 100 hours, or maybe they went to bed at that time, you know. Let's look at ANSI code. So last week I showed a little bit of formatting on how, like, when we were taking our knowledge is power, we changed the color of the text on the inside. But we can do more than just color. We can also make the text bold. We can make it italic. We can make it underline. We could also do strike through, and then reset is just putting it back to the default text. I think I called it default color last week, but that also removes out any strikes, underlines, italics, and things like that. And not all terminals support that, all of these different commands. So we'll see here an example where one of these is not supported in Google Colab, but then if you do it in PyCharm, it is supported. So, and that'll be the strike through. So we got the color codes. We looked at this one last week. Okay, so you put one of these in as a string, and it's going to change the color of the text. And I'm saving them as a variable, so that way I can do it as an F string to make it easier to read. And then finally, here are the strings for underline, italic, strike through, bold, and the default or reset that we had last time as well. And let's go ahead and apply these. So we're doing bold. We're going to make it red. We're going to have the text that we want. So this is bold red text. And then we're going to say reset. Okay, and where did I miss? Red is not defined. Oh, because I didn't run it. So let's run the colors. Come down here. So when you're in Google Colab, you have to run the previous blocks before you can run later blocks, if those later blocks depend on it. In this case, I have red up here in this block, but we need it down here all for the color, so that's why I get that little error. So run that first block, then we can run this block, and boom, good to go. So we're going to do bold, red, string, and then we're going to reset it so it doesn't affect the next text. In fact, I could say back to normal right here, just real quick, show, and you see after the word reset, it's back to not bold and not red. You can also do the underline, pick a color, and you're going to get green underlined text. In this case, I want italics, I want it to be purple, and it's going to show purple italics text. Now, the one that didn't work in Google Colab is the strike through, but it did take in the blue text, and this is blue text. Let's pop over to PyCharm real quick. I'll have a quick example. Let's minimize that. There we go. Okay, showing up on the screen there. If anybody has any questions or comments, I'm watching the chat, so just speak up, let me know, so I can explain anything more thoroughly. Oh, sorry. Is there a command that strips return keys at the end of a string? There is no such thing as a return string. If you're talking a new line, yes, you could remove new line. Not when using input, but when doing an IO grab lines from an ASCII file. So yeah, I think you're most likely talking about the new line /n that it throws on the end of files. You wouldn't use strip. What you would do is you would, I'll talk about that next weekend. But yes, there is a way to do it. I just need to refresh my mind on it because I haven't had to do that one in a long time. But when you import in like generative AI through an API from like Google and stuff, every new line will have that /n or /r. And basically what you can do is you can either, next week we're talking about stripping. So what you do is you'd strip out the last two characters of each line as you import it in and then add it to a list. And that actually removes that /n or that /r by removing those last two characters and stripping. So that I will specifically talk about that next week. So great question, Herv. Sorry I didn't see that in the chat. I actually had two windows open on the left side there. So hopefully that answers yes, you can do it. Stripping is an easy way to do it, and there's also a couple other ways. I'll cover all of those in next week's chat because I didn't want to go into stripping until we started covering lists. All right, so back to what I got here, and then yeah, speak up if you guys have any other questions. And nice to have you today, Herv. I know sometimes you guys are real busy and you have your own schedules, and sometimes you catch the live streams later on, which is perfectly cool. I think they do help the students because I see things we talk about show up in the programs and it looks really good. So strike through. What did not show up in Google Colab, however, if I run it here, so this is the same text. I got the colors. I have the different ANSIs for italics, underlines, save them in variable, and I have the same text here. But if I run it, you'll see strike through works just fine in PyCharm. You could also run this in, let's see if I can get it to show up real quick. I don't know if I have that window set up. You can run a command prompt. Okay, we'll type in Py space, and Py did not show up. Let me add in on a quick window so you guys can see it. Window capture. Yep, that's fine. Command prompt. Okay, command prompt. Just capture. It did not show up there. Let me try one more option here. Take this one out. We'll hide that. Little impromptu here to show the command prompt, show that it may or may not work inside another image type. Display capture. Command prompt. Let me give this name. It's working. I'm using OBS to stream. So yeah, there we go. Okay. We'll go with this one. Okay, there we go. Now you can see the command prompt. So we'll do Python. All I did is from PyCharm. All I did is copy the location, and then you can open your command prompt. Let me see if I can show that real quick. So CMD opens up your command prompt, and you type in, if you have Python installed on your computer, then your Python will understand that. So you type Py and then paste, and there we go. So in here we also see that the strike through text also works in your command prompt as well. So only in Google Colab so far that we've seen does it not work. But inside PyCharm, inside a command prompt, if you're using other applications, it may or may not work. So if you're developing for multiple systems, I know a Pythonista is the one that a lot of the iOS users, so if you're working on an iPad, you would have to test it on that one as well. You don't want to just test it for one system and say it works for everybody. So strike through did not work for Google Colab. It does work here. And you saw a little bit how to pull it up in command prompt just to give it a test as well. All right, back to our Google Colab. So main window, hide that one. Let me pull up our Google Colab. And I get reset back up here. All right, there we go. Back to Google Colab. So no strike through here as we saw it, but it does work. You just have to be in a different terminal format. Okay, continue on. We looked at ANSI characters. We're going to look at hex, binary, and octal formats. So I don't think they went a lot into binary and stuff in the intro to computers that some of you guys may have taken last semester. I believe that's a requirement for this course here, or going a lot into the hardware. But computers think in binary. So sometimes you want to know what is the binary value, or you can also do binary operations to the bits themselves for increased efficiency. However, you may not know what the value of the binary is. Usually you don't want to print it out unless you want to like look really cool, but there are sometimes reasons to print out binary. Octal is just another form of counting within a computer system. And then you also have your hexadecimal. If you're looking at colors, you may do that in hexadecimal. Do I color? Okay, yeah, we'll look at colors a little bit later on also at hex when we start doing the percent specifiers. But yeah, let's go ahead and hit play on this one here. So we're taking the number 215. If you know binary, a binary, an 8-bit binary code, so binary is a 0 or 1, that'd be a bit. A bit is a 0 or 1. You combine 4 or 8 bits together, that gives you a byte, and it goes from the value of 0 to 255, which means it has 256 total values because 0 is one of those values. Let's go ahead and hit run, and you can see as hexadecimal, so hex stands for hexadecimal, we can see that the number 215 has the value of D7. These are the bits that it'll utilize. So this is the 128-bit, 64-bit, 32-bit. All right, let's see. We got the 1s, 2s, 4s, 8s, 16s, 32s, 64s, and 128s. Yes, so I was going the right direction. It's easier to start from the right to left. And then as an octal code, so if you know, the byte is 8 bits. 8 is octal, so if you want to look at the octal code, that'd also be 327. And what you can do is you just do the colon and X for hexadecimal. That makes sense, right? B for binary, makes perfect sense. And then O for octal. Okay. Look a little bit more in. Percent formatting. So we're covering a lot of different formatting things here, and I made this the week 3 Google Colab file. Since it's web-based, everybody can check it on your whatever documents you might have. You can look up this information later on, and you can also run through all this code. You can hit run, you can save these, you can change things and stuff like that. Check it out. Or if you ever need a refresher on any particular formatting stuff, you can always come back to these Google Colab files and check them out. Or you can come back and watch this amazing live stream and find the right place and look at the information as well. Let's say we want to do percent formatting, where we want it to automatically add that percent. So we have the value 0.85, which is the decimal version, decimal format for a percent. What we can do is we can just do .2, or we have our variable colon .2 for the 2 decimal places, and we're going to have our percent. And there we go. It gives us a percent with 2 decimal places. We could also say .1 if we only wanted 1 decimal places. So this person got an 85.2, an 85.2%. Now let's go into formatting specifiers. Formatting specifiers are a little bit of the dot format that we looked at before, and a little bit of the formatting that we got with the F strings as well. But you use these percent and then a formatting specifier. So %S stands for strings, %D stands for integer, %F for float, %x or capital X for hexadecimal. Normal standard is capital X because hexadecimal is usually always uppercase. For easier reading, because numbers are very tall, so you don't want your letters to be small, you want them all to be the same size. Scientific notation. If you want to force a value into scientific notation, such as you're doing significant digits or something like that, that's nice to have. And then let's say you want to actually put a % sign in there. If you're doing format specifiers, you can't just put % in there because it doesn't know how to read that. All right. And just like the dot format, these are placeholders for a variable. So in dot format, what we did is we had an open bracket and open bracket. In this case, it's a little bit more readable using these format specifiers or % specifiers. So in this case, we have the variable Alice, and we're going to say hello. And what we're going to do is we want a string variable to come here. So instead of an open bracket, close bracket, we put %s, and that tells it that to expect a string variable or string value. And in this case, you close your quote, you add the %, and then you put your variable name here. And because we know Alice is indeed a string, you can see it up here, string, it's going to put it in the place of the %s here. If you have a integer value here, let's say we had number 32, but you put %s over here, it actually give an error code. Let's try that just to see what'll pop up. Okay, 32, and we tried to do a %s. Oh, it said hello 32. Oh, because it sees the 32 as a string, so it's forcing to be a string. So %d is specifically for integers. So we have age equals 25. I am %d, so it's looking for a percent, and it's going to print out I am 25 years old. Floating points, you do %f, same thing. 1999, so the cost of the item is 1999, and the nice thing here is just like f strings or formatted strings, we can also control our format here. So we have our %f, and in the middle there we say we want 2 decimal places, and it'll give us a 2 decimal place fixed float value. You can do multiple specifiers, just like you do multiple .format variables. You can also do multiple specifiers. Let me fix the spelling on multiple. Oh, all right, there we go. Multiple specifiers. But at the end, you have to encapsulate them or put them inside parentheses separated by commas. If you do it just a single one, you do not need a parenthesis. If you do more than one, you just have to put in parentheses. And basically, this reads this as a tuple. A tuple is a immutable object. We'll learn a little bit more about those later on when we start looking at our lists and dictionaries and stuff like that. So what it's going to do is it's going to take variable with Alice, age 25, and a float value of .4. So we know we're going to get a string is an integer, years old, and her height is float of 1 decimal place feet. Our %, and then our 3 variables. So name will be the string, age will be the integer, height will be the float. We run it, and we get our sentence. Alice is 25 years old, and her height is 5.4 feet. If we want to look at hexadecimal case, so RGB, your computer screen, if you're doing, most programmers think in RGB, red, green, and blue. If you look in really close to your computer screens, you put your eyes really close to those computer screens, you'll see it's made up of tiny, tiny little red, green, and blue. If you were back in the day, the 80s and 90s, when I may or may not have been alive, with those giant CRT tubes, they were 480 resolution. So you could actually put your eyes up pretty close to TV, and you could actually see tiny little red, green, and blue rectangles all over the screens. I probably just totally dated my age and dated myself on that one, but yeah. I just keep glancing to the left here to make sure nobody's chatting. So let's go ahead and turn that RGB value, because if you're doing graphics art, you have hexadecimal values to show your different colors. You may also be using CMYK, which is another graphics artist, or a game art or game graphics might use CMYK for their graphics, and they have to convert that as well. But in this case, we're going to convert RGB over to hexadecimal values. So we're going to take our, we'll look at the next one, okay? 3 numbers. These could be RGBs, and we're just going to show them capitals and lowercase. Got a little ahead of myself on the RGB there. So the number 196 is C4 if we use the %x, capital C4 if we use the %big X, uppercase, and then if we do it, the number 0 is hexadecimal 0, and the number 255, which is an entire byte, is FF. So in hexadecimal, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. For counting, it's 16 characters. So you might have heard of like the 16 basic colors. So if you play an old Mario game, like Mario 1 from back in the day on the Nintendo, it only had 16, it was 16-bit color. And that's all it had for that. So you went from 0 to FF. We were talking about RGB hexadecimal, so let's take red as a value of 126, because it goes from 0 to 255, because each number is a byte in itself. Green will be 255, or FF in binary, right? And then 254 for blue. We're going to do that as a, we have a %D, and %D, so that means I want to show a integer. You can guess what the 3 integers are. In hex is %x, %x using capital X's. You can guess what those numbers will be. But you can see here at the end, I'm doing red, green, blue for the integers, and then red, green, blue for the hexadecimal. Hit play. Red, green, blue values. There's your numbers. In hex is 7EFFFE. And what you can do is, like, if you're using Adobe Photoshop, or if you want a free one, so Adobe Photoshop is paid, you can use GIMP, G-I-M-P. That is a free graphics editing software. Fantastic. It does nearly everything that Adobe Photoshop does, and it's free. If you want to convert from RGB values to hex, this is an easy way to do it, and you know exactly what the hex value is. If you want to do scientific notation, so like, again, if you're doing chemistry, physics, or mathematics, and you need to show a really large number or a very small number in scientific notation, then you can use %E, and it'll change that into the E-04, or essentially 10 to the power of whatever. So here, for our large number, we got 1.23. So these are the same number up to the E, except this one you add 8 decimal places, and this one you subtract 8 decimal places to make it small. And that's the easiest way to read it. It'd be the same as 1.2 blah 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 times 10 to the 8th, or times 10 to the -4, scientific notation. If we want to do an actual percent, you can't just put a percent in a string if you're doing percent specifiers. So if you have this percent specifier here, you can't just put it into a string. To put a percent, you have to go %% to display an actual percent. So my integer equals 85, my float equals 85. I'm going to take in a %d as an integer, but I want to show percent sign after that. I have to do a %% on this test. This one here, I want to do display a percent for a % integer with a % float with 2 values. Let's hit play and let's just see how this one turns out. All right, turns out way simpler than it shows up here in the % specifier. So we have our integer and an actual % sign, and then here we have the % sign, and then we have an integer %, and then a 2 decimal float value with a %. Just to demonstrate, let's show what it would look like if you just try to do a single %. This is a single %. All right, we got our string. We will do, let's do a decimal. So let's go % integer, and then we're just going to put just a single % sign. This % is a single %. Okay, so what we'd expect to see is something similar to that second line there. You can display %, the sign, and let's go with %, and we will go with my integer. All right, let's hit play, and we should get an error out of this. Okay, and it's good to try things like this just so you can see what the errors show. So as I told you, you'll get an error here, and it says not enough arguments for format string. So basically, it's looking at this first % sign here, and it's saying, oh, I don't know what to do with this. What do you want to come after? What kind of symbol do you want to show? Do you want it to be a %D? Do you want it to be a %S? What do you want this to be? There's not enough arguments to format this string. Let's take this one out here, and what we would expect is this is a single 85%, right? So this one makes more sense, but still we're just using a single % here. It should also still give us the same error, right? An incomplete format. It's a value error. So it is getting the 85, but it says this is an incomplete format here with this second one. So we'd have to add %% to actually show that %. We'll hit play this time, and there we go. Now we have an actual % sign after the 85. All right, thanks for those who've been sticking around. We have one more section to go. I like to always talk about this one. Your code is not just your code. So therefore, your code needs to be readable or have readability. Simplicity is important, but so is efficiency. If you make all of your code for your entire program in one line of code, you can do that, but nobody's going to be able to read your code. So it is important to keep it simple and efficient. We got 6 cells to go through here. We're going to look at one example on taking it. Oh, is there a / specialized character in Python? Yes, there is. The / character, it's actually an escape sequence. Boom, boom. Let's see if it shows up. Yeah, and see what it does. It just gives you the single /. It's an escape character. But you know what? Let's try an experiment. I've never actually tried this one. I don't think this one exists. Let's try it. %/, and we'll see how this one looks. Yeah, it doesn't know what that is. So that's not a % one, and I didn't think it was. So yeah, if you want to do it, just do the //. Is that the right slash? Oh, no, the other slash. There we go. That slash. So if you want to do that one, it will show up as a single slash. So same thing like a new line or a tab, because you have your new line, you have your tab, you have your and then your slash. Those are all escape characters. So if you want to know more, so we got our single slash, we have our new line, and then we have our tab, which is why I gave this massive indent right here. So if you wanted to look up more into escape characters, there are other options. I think there's like 12 or 13 different escape characters. I think I talked about it in a previous live stream, but maybe I didn't go into as many options there are. Just look up Google escape characters Python, and you'll see the whole list. 10 or 12 so escape characters that they have. I think there's also escape percent. No, not that one. Okay, I don't remember off the top of my head all the different escape characters. Yeah, just Google it and you'll see the list. It's not a massive list, but they are very valuable to know. Right now in the course, we kind of only looked at the /n for new line and /t for tab, just to introduce people to it. But to take it to that next level, I know your programs have been pretty darn good, and you like to take it to that next level. Yeah, look those up. All right. Okay. Let's look at readability, simplicity, and efficiency. A lot of our programs and the way we've been teaching so far is keeping things simple. So text 1, we get an input, enter the first number. Then we change that number into an integer. Then we get another second number and we save it inside text 2. We change that one to an integer. And then what we're going to do is we're going to multiply the first integers together to get the square of it. And then we're going to multiply the second integers together to get the square. We're going to add them together, and then we're going to print out what the results are using an f string. So the sum of the squares of the squared value of the first number, the squared value of the second number, add them together, and that'll give us a total. That's what we expect. So whenever you're looking at code, run through your mind, look at what the code's trying to tell you, and then when you hit play, if there's no logic errors, the code should show you what you're expecting. I know when we get to our loops section, I start adding logic errors into the assignments. So the code is correct, but there's logic errors. That's something you always got to look for. The code should match what your mind thinks it should be putting out. So if we put in the first number, 2, that should give us a square of 4. Let's get a second number. Let's go 3. That should give us a square of 9. Add those together, and we should have 13. And that's correct. So the sum of the squares is 4, and 9 is 13. But this is a lot of text here. It is simple, but it could be easier to read. So let's look at one step to make it a little bit easier to read. All right, we could do multiple math operations in a single expression, right? We don't have to do put the numbers, square them, assign them the value, put the numbers here, assign them the value. When you assign to a variable, you're actually assigning it to a space in memory, and now the Python memory manager has to manage that. So there's two different forms of efficiency when you're looking at a program. There is memory efficiency, and then there is time efficiency. Time efficiency, a lot of people may or may not, you'll definitely hear this if you stick with computers, but you'll hear big O. Big O is your big omega value, and that's the overall time efficiency or processor efficiency of your program. But there's also the one of memory efficiency. If you keep assigning all of your values directly to memory, then you pull them from memory and put them in an output, you're not being memory efficient, and you're actually being not time efficient as well. So what you could do is we can actually compact that down. We can take this entire block up here and can compact it down here. We have our input, we have our int, we store it in 1. We have our input, we cast it to a variable, and we store it in 2. And then we go ahead in a single line, we go ahead and combine them together, and we save it as 2. And then we go ahead and print out the sign. So these 4 lines do the same thing as all of these lines up here. And it is relatively easy to read. In industry standard, everybody would be able to read this. Let's hit play. We'll do 2 again, 3 again, and we got this first value, the second value, and what they are added together. 1 times 1 plus 2 times 2. gives us the total. That was 9 plus 4, 13. Yep. Okay, look up here, same things. Except in this one here, we actually overwrote the value of 1 with the squared value and overwrote the value of 2. So therefore, the only numbers to show for 1 and 2 are the squared values. Here we have the options. When we do it simpler, we can still show the original values here. But you know what? We can make this more efficient, still keep the simplicity, and keep the readability. So let's look at taking it another step. We can combine it from 4 lines into 3, and it's just as readable using an F string. Okay, so just like before, we're taking our input, casting as an integer, storing it, but this time we took out the total line, because do we need the total line? No, we don't. We can easily put that into our F string, so we still get the value of 1, the value of 2, and then instead what we do is we do the evaluation of adding them together inside the string itself. And it's super easy to understand. I know I'm taking 1 times 1 plus 2 times 2, and it's going to give me the value in this spot here. When I hit run, it should give me the exact same value. So let's go with a 2. Let's go with a 3. Exact same output answer. We can make it even more efficient still. 1 times 1 is squared, right? And we learned last week about arithmetic. You can either do POW. So if we want to use math, I'll actually show that one as an example after this. So we can use the asterisk asterisk to show the power, and it's even easier still to understand. So we take our input, cast it to an integer, we store it. Take our input, cast it to an integer, store it in the second variable. In here, this is even more easy to read because we're going to do the sum of the squares of 1 and 2 is 1 squared plus 2 squared. As simple as that. We could even change this to a 3 if we wanted to look at it cubed and add it together, right? If we run it, it's going to be the exact same thing. And this is readable, but this is readable and even more simple. So we're taking it more and more simple. Let's go 2, let's go 3, and we get the exact same value. I also mentioned the math library. I didn't think about adding this one, but this would be a good example. So import math. Okay, I think I might have done import earlier in this, but that's fine. Google Colab is kind of cool because it'll actually do completion for you. But let's go ahead and copy, paste. And in this case here, we're going to use the math library. Oh, it put it down for us. Well, that's cheating. We don't want to do that. Print f the sum of the squares of 1 and 2 is brackets, and that should be that. Okay, and we're going to take math.pow of 1 plus math.pow. You see I got a space there between on both sides of the plus sign. I have equal spacing on both sides. That is a standard practice there. 2. I think this should give us the right value. I hate doing math in public, but this should be the right way to do it. 2, 3. Oh no, I did a math error here. Pow expected 2 arguments. Oh, sorry. I need the power. So the variable 1 to the power of 2, and the variable 2 to the power of 2. Yeah, it's a foo bar. Which is funny because I covered the pow last week also. There we go. And the sum of the squares of 2 and 3 is 13. In this case, we have a float. If we didn't want the float, we could always do int, but then you always run the risk of losing precision of numbers by cutting off those additional variables. Okay, so I'm casting it as the final output as an int, and there we go. Exact same as before. So you can do it with the asterisk asterisk, which I actually think is easier to read. But if you want to use the math library, you could also use the power. Because the power actually does, we covered this last week also, so I don't want to beat it down, but you can also do the modulo as the third number. So if I want to do the modulo of 2, let's go with the modulo of 2 and the modulo of 3. It's going to ask, is this divisible by 2? What's the remainder? And divisible by 3, what's the remainder? And it's actually going to add those remainders together. In this case, it should be 0, but let's check. 2, 3. Oh no, I got an error. Math in public, got 3. Okay, in this case, I'll have to double check that one. I thought we could do the modulo on power, but in this case, it's taking the variable to the power of 2 and we'll just leave it at that. Okay, and the sum is 13. I really thought it would take the modulo, but I could be mistaken. So that's all I have for this week. If you guys have any questions, you can ask in chat. I'll be around for just a couple more minutes. You have this live stream will be available immediately, and then I'm going to have the edited version to cut off the first 15 minutes of stream is starting soon. And then this Google Colab is linked inside the class announcement. It is also linked in the Discord, and it is also linked in this YouTube video as well. So I hope you all appreciated it. Next week, we'll start looking at slicing of our strings, and I believe next week is conditionals also. We'll be looking at conditionals for my $sign. So x equals 0, x is less than 100, x plus plus. So you're looking like a for loop. Yep. Print, thank you, professor. Yeah, that would be a lot of fun. Okay, hey, thanks for the for loop. You're getting ahead of the curve on this one. That's a lot of thank you, professors looping through that one, though. All right, you all have a good day. I'll end the stream. I got to do the fancy end the stream. Hold on. There we go. Stream offline. You all have a good day.